Finishing out the sample test, question 15 asked me to solve, as I had to in the ones before. Difference here is I have two different roots. Basically, as long as I have the roots isolated on different sides from each other, I can still use my problem-solving method of squaring both sides. When I square the left side, I also have to square the right side. In each case, the squared undoes that square root. So it leaves me with 5a minus 8 equals a plus 4. Next step, take all the letters to one side, take all the numbers to the other. So I'm going to add 8 to both sides to get rid of this negative 8. I'm going to subtract 8 from both sides to get rid of that positive a. On the left side, that leaves me with 5a minus a, which is 4a. On the right side, it leaves me with 4 plus 8, which is 12. When I divide both sides, I get a equals 3. For number 16, it's really just asking me to put things into the form that the quadratic equation could use. So it starts out with 8x squared plus 7x equals 7. It's close, but not quite what I need in order to find a, b, and c. The reason is I have something on the other side that isn't 0. So before I can start to find a, b, and c, I'm going to subtract this 7 from each side. Then I'm going to write in descending order, starting with the x squared term, 8x squared, then the single power of x term, plus 7x, then the no power of x term, minus 7, equals 0. Only when it's in this form can I pull out a, b, and c. Highest power of x, single power of x, no power of x, equals 0. So, what's in front of the x squared term is my a. The sign included, what's in front of x, is my b. And the sign included, the last term without any x's, is my c. So here I would write 8, 7, negative 7. Reason we want to know how to find a, b, and c is so that we can use our quadratic formula. Even if we were going to do this in person, we still would have given you the quadratic formula. I literally just write it on the paper. So my goal here is for you to be able to use the formula, not that you need to have the formula memorized. The formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Things that trip students up the most, this negative b doesn't really mean it's always negative. It means it's the opposite sign of wherever b starts. So if b starts as a positive number, negative b will be negative. But if b starts as a negative number, this is the opposite of a negative number, meaning it would turn into a positive number. I highly recommend that you do the math underneath the square root sign, separate before you start to combine things. Really what happens under this square root sign is going to be different in how you want to input into Cengage depending upon whether it's a perfect square or not. So by doing it separately and seeing whether it's going to give you a perfect square really is going to change how you proceed and how you enter your answer. So first thing we're going to do when we look at 17 is identify a, b, and c. It's in the x squared single power of x, no power of x format, so I can pull out a equals 1, b equals negative 5, c equals 6. If I write this into my equation, negative b, the opposite of negative 5, is positive 5, plus or minus the square root of negative 5 squared minus 4 times 1 times 6, all over 2 times 1. Cleaning this up a bit, it becomes 5 plus or minus. Negative 5 squared is 25, so the root of 25. 4 times 1 is 4, times 6 is 24. So minus 24 over 2. That becomes 5 plus or minus the root of 1 over 2. Good news, root of 1 is a perfect square. I know what the root of 1 equals. It equals 1. So this is just 5 plus or minus 1 over 2. When everything works out to whole numbers like that, I want to split off, do it once as the plus, once as the minus. So if I do this as 5 plus 1 over 2, that gives me 6 over 2, or 3. If I do this as 5 minus 1 over 2, that gives me 4 over 2, or 2. So my final answers to this problem are x equals 2 and x equals 3. For number 18, again, I'm going to start out by making sure that it's x squared term, single power of x, no power of x in descending order, set equal to 0. This is the way I want it, so I can pull out what my a, b, and c are. A equals 1, b equals 4, c equals negative 1. Now as I plug into my formula, x equals negative b. In this case, since b star is a positive, it becomes negative 4 plus or minus the square root of b, 4 squared, minus 4 times 1 times negative 1, all over 2 times 1. When I go to do my next step, the negative 4 stays, becomes plus or minus the root of 4 squared is 16, minus 4 times 1 is negative 4, times a negative 1 makes it into a positive 4, all over 2 times 1 or 2. When I combine under the square root here and get negative 4 plus or minus the root of 20 over 2, that really should be a fine answer to put into Cengage. Technically, I could take out a root of 4 here and I could reduce things by 2, but I'm pretty sure it would accept this answer right here, as long as that's not an exact perfect square. So your goal really is to make sure that you clean up what's happening under the root. If it is a perfect square, find 2 answers. If it's not a perfect square, write it as 2 answers, once with the plus, once with the minus. So really the way it would go into Cengage is it would be negative 4 plus root 20 over 2, comma, negative 4 minus root 20.